So this is GATE 2010 question number 4, which is a Laplace transform based question. It is given that the function f of x is 0 when x is less than 3 and x minus 3 when x is greater than equal to 3. Then the Laplace transform of fx is what we require to find. So let's jump into the solution. So this is the fx which is given in the question. So we have seen that this is the function which is given, that is x less than 3 it is 0 and x greater than equal to 3 it is x minus 3. Now we have to find out this Laplace transform of this particular fx. So the definition of this Laplace transform of fx is given as 0 to infinity fx e to the power minus sx dx. This is the definition of the Laplace transform of any function. So here this function is given. So what we write from 0 to 3, that is, since it is starting from 0 to infinity, from 0 to 3 it is 0, the function is 0, e to the power minus sx dx, and from 3 to infinity it is x minus 3 e to the power minus sx dx. As per the given functions, I have written the Laplace transform. Now the first integral being the function being 0, this becomes completely 0. But the second integral is therefore the only integral which remains of this Laplace transform. So the Laplace transform becomes, this is 3 to infinity x minus 3 e to the power minus sx dx. Now let us solve this particular integral. So what I have done is that I have substituted t as x minus 3. So dt will be equal to dx because minus 3 is constant. Now if I put the limits, if x is equal to 3, then t will be 3 minus 3 will be 0. If x tends to infinity, then t will tend to infinity. Therefore the limit becomes 0 to infinity. X minus 3 is nothing but t e to the power minus sx. Now x from here comes out to be t plus 3. So that is what I have written. So e to the power minus s t plus 3 dt. Now this, from here it is clearly seen that e to the power minus 3s can be taken outside the integral because the integral is with respect to t, not with respect to s. Therefore it can be taken outside. So e to the power minus 3s comes here, 0 to infinity t e to the power minus st dt. This is the integral which we finally get. Now can we reduce this to a gamma integral because the limits is 0 to infinity, and it can be reduced. So if I take now y is equal to s into t, dy will be equal to s dt. Now if I put t is equal to 0, y will be 0. If t is equal to infinity, just put it here. If t is equal to infinity, then y will tend to infinity. Therefore the limit will remain the same. E to the power minus 3s I have already taken common, 0 to infinity. Now instead of t, it will be nothing but, t will be nothing but y by s. Therefore y by s, e to the power, this st is nothing but y. So e to the power minus y, dt is dy by s from here. So we get e to the power minus 3s, and this s into s becomes s square, which can be also taken outside this integral because the integral is with respect to y. So it is y e to the power minus y dy. This is the integral which we get. So e to the power minus 3s by s square, I have written it again, 0 to infinity y e to the power minus y dy, and this is the gamma integral. So I have written this gamma integral 0 to infinity y e to the power minus y dy as I1. Now we know that the definition of gamma integral is that gamma of n is 0 to infinity t to the power n minus 1 e to the power minus t dt. So if we now compare this with this particular integral, then we can see that n minus 1 should be equal to 1 because it is y to the power 1, and hence n will be equal to 2. Therefore I1 will be gamma of 2, and gamma of 2 can be written as gamma of 1 plus 1, which is nothing but 1 gamma 1, which is, and this gamma of 1 is actually 1. Therefore this I1 integral is actually 1. This particular integral I1 is actually 1. Therefore what we get is nothing but the constant part which we have here, e to the power minus 3s divided by s square. So I think D is the correct option, not A. So if we come to the question again, in the options, s to the power minus 2 e to the power 3s is given here. This is the correct option, s to the power minus 2 e to the power minus 3s. D is the correct option in this particular case. Thank you.